Hello, so this is my tutorial. So this is my video on my what I've been working for my graphics novel project. This is I I picked up an interest in frame buffers as a concept, and from this I did two things in one. Well, my main goal was to make mirrors, was to make a non-Euclidean world, but for the scope of my final project, I've decided to focus on mirrors as they use frame buffers and independent cameras separate from the player's camera in order to render the reflection as seen here. And the way I first got started with frame buffers was that I created a second camera, and I just wanted to get used to the concept of frame buffers, so I created a second camera behind the current camera facing the opposite direction. And wherever the main camera would go, the rear camera would also follow, and the what's seen behind is shown in the top left corner. And if we turn around, we see the quad we previously saw. We turn around again, we see the quad we previously saw. And that's where I first got started, was practicing frame buffers and using multiple frame buffer objects and cameras. And so the next thing I wanted to do was not just use frame buffer objects as seen here. If we enter wireframe mode, these are actually just quads. This is not every object. This is just this world is just a texture. So the main idea is now, within this texture, we want our mirror to be inside of the texture, not an independent quad. So the next thing I wanted to do was create a new class derived from our textured quad object here, object.cv, the object class, and we wanted to create a mirror class. And what the mirror class would do is do essentially the same things, but with a twist of copying some of the functionality I got from the frame buffer, which includes binding, updating, unbinding, and drawing. And this is how it would work. And basically, we would treat our mirror the same way we treat the frame buffer as we load our custom image into it and into its and each mirror would be assigned to a camera. And whenever we iterate through the mirrors, we would want to capture the view from that camera and then store the frame buffer object for that inside the mirror class. And then when we would render the quad for the mirror, that's when we would paste the frame buffer object texture onto the quad. But then one thing it had to do though was that we have to make sure that no matter what, the first time you ever draw the mirror quad has to be a plain texture. And then after that, after we've generated our very first, and then immediately after rendering it for the first time, rendering as just a regular textured quad, we would then create our buffer, and then from there on out we would bind our frame buffer object as our texture. And this creates the effect of recursion, as we can see here. As we can see if we look closely enough, we can see these two quads that we're currently staring at right now. We can see them again here, because back there this quad is reflecting, and we can see its reflection. And the way that it works in OpenGL, that it just stacks on top of each other. That the camera what it sees here, it builds on top of it, and it continues to build on top in a recursive manner, but not in a way that it causes an infinite non-terminating loop. And then the final thing I implemented for this assignment was to add perspective to the camera, because add perspective to the mirrors, because as I'll look for the diagram here. Within this diagram, the problem is that suppose we're looking forwards and it reflects forwards. That makes sense. But then if we look at it from an angle, we don't want it to reflect forward, or else the mirror would look flat and unrealistic. We want it to also reflect at an angle. And within here, I performed the calculations based on the mirror's position, and based on the mirror's camera's position, and then based on the player's eye, I would calculate I would calculate a vector representing the direction, and then I would reflect it across the forwards line for the mirrored quad, and that is how we're able to achieve this perspective. So, for example, if we get really close adjacent like this, we can see that it kind of scrunches up, and our line of sight is limited. We are facing that way, and then if we face head on, we can see pretty much the recursive aspect of it all. And then if we take it from a slight angle, we're able to see that this captures this, but not in a flat manner. It's angling here and then capturing this area. You can see how it gets a little closer to the wall here.